Passiamo al prossimo talk, Exabeam. Abbiamo solo Antonio, immagino. Abbiamo anche Sergej. Ok. Abbiamo Sergej Hafner e Antonio Iannuzzi. Spero di non aver sbagliato la pronuncia.
Perfetto.
Abbiamo due talk tra i quali scegliere. Il primo è AI-based Security Analytics Delivered via Cloud e il secondo è superare le minacce informatiche, come l'AI e la UE hanno trasformato il SOC.
Posso dire giusto una cosa?
Sì,
diciamo, a spiegare anche per quale motivo, vedete, è fondamentalmente una riga e mezza. Sergej è un ospite internazionale, è responsabile di tutto il team di prevendita in Exabeam, è un collega in Germania. L'abbiamo coinvolto ieri di frettissima perché il mio collega tecnico che doveva essere oggi qui con me, Luca Pesce, purtroppo ha avuto un problema di salute e quindi non riuscirà ad essere con noi. Ovviamente la sua presentazione, come dire, è stata sostituita da quella di Sergej. Sergej è una persona molto brava, molto competente, ovviamente sarà in inglese, però è altrettanto una presentazione estremamente valida, sebbene, come dire, non ci siano poi molte indicazioni rispetto ai contenuti della sua presentazione. Ora a voi la scelta.
C'è un piccolo problema. Ecco, il problema era che il video stava sopra il QR code, quindi non potevano votare.
Ok.
Vediamo un po'. Immagino che siano ancora troppo pochi. Questo è come cambiano all'improvviso.
Siamo sulla...
Mi sa che è uno di quei
sulla linea, sul finish line,
quegli argomenti
50-50, non ci posso credere. Incredibile. Sembrano l'Inter e il Napoli le ultime partite del campionato.
Sergej è preoccupato. Diamo ancora 10 secondi. 9.
C'è un recupero.
8. 7. 6.
Sergej.
Mi sa che
ha vinto Sergej.
Ha vinto Sergej.
Secondo me avete fatto un'ottima scelta.
Attenzione.
Ops.
Dovrete farli tutti e due. No. Sergej. Ok.
Avete fatto un'ottima scelta.
A voi il palco.
Grazie Sergej. Up to you.
Yeah, hello everyone. It's like a close race between Germany and Squadra Azzurra, right? So always the same, close. Let me share my screen very quickly. Hello, can you hear me?
Now we can hear, yes.
Great, yeah.
Thank you. Yeah, you can go ahead, thank you.
Yeah, hello everyone. I just was saying that it's like always a close race between Germany and Squadra Azzurra, you know, so this is same here, so it's head to head already. Yeah, hello everyone. Thanks a lot for the opportunity to present to you, and apologize that I cannot be on site today. And also, I cannot present in your local language. Sorry for that. My name is Sergej. I'm a sales engineer manager here in Central Europe. I'm 4.5 years with Exabeam, and I'm based in Germany. So today I will talk about how to detect credential-based attacks, so such as compromised user accounts or malicious insider, using Exabeam's machine learning AI behavior-based risk detection engine, and why SIEM, especially with UBA, is the perfect tool to detect such kind of attacks. Okay, for those you maybe never heard about Exabeam, so Exabeam is a SIEM vendor based in US, and some of you will surely be thinking now, oh man, another SIEM. Yeah, you have maybe made your own experience with the SIEM already. And when I talk to customers and ask customers feedback about SIEM system, it's like, it's very costly, cost a lot of money. It's always or sometimes a never-ending project, very complex to operate usually, especially creating, maintaining all these detection rules. And then it's often complex to analyze. Yeah, often the context is missing, and you need often an expert or expert knowledge to analyze the logs. And in the end, after you spend a lot of money, resources, and time, it still end up with a lot of false positives, or a lot of alerts. Most of them are false positives. and then SIEM was not able to detect a real attack anyway, right? So in this way, I fully agree. Yeah, I worked for different SIEM vendors before, and I have made the same experience. But Exabeam is a little bit different. Yeah, Exabeam is a relatively new player on the market, and we have taken exactly the challenges I talked before. And today I would like to show you how a modern SIEM with UABA and our new detection engine and investigation engine can be a key factor, helping you, supporting you, uncovering especially these credential-based attacks. But why I decided to talk about credentials today? So when you look at the statistics, yeah, it's a very relevant topic. So as you see, 40% of the attacks are based on credentials. And even the second place, phishing, yeah, phishing is, let's say, also, or let's say, what's the goal of phishing? Phishing is also to compromise an account. So we are again back to credentials. So that means I don't need to have the most sophisticated malware anymore, or I don't need to exploit vulnerabilities anymore. I can simply take control of a completely legitimate account that exists in your organization, and I just can log in. Now, this is the reality. And what do we do to prevent that? So what options do we have to detect such credential-based attacks? So we use EDR, we use multi-factor authentication, we use zero trust technologies and other prevention and detection technologies, which is, don't get me wrong, absolutely necessary and important. But attackers still find some way around all these technologies, yeah, because otherwise we wouldn't have these headlines about successful attacks almost every day. And you can believe me, companies like Uber, Nvidia, all these companies use MFA, they all use EDR and so on. But what can you do, for example, if I would reach now to your admin, offer them $10,000 for a regular account and an NFA token? Now, this is the question I always ask to a CISO. How do you prevent this? What are you doing about it? It has nothing to do with technology, okay? And the best answer so far I have seen, I need to make sure I pay my admins enough salary and that are even not considering such an offer. And once the attacker is in your network, yeah, it is very difficult to detect if an account has been compromised. It's different with ransomware. If you have ransomware, you will immediately see it because you cannot access the files. With such compromised accounts, that compromised attacks, it's a little bit different because they have used my credentials, log in by using my valid account and pretends to be me. And the worst thing is if something like this goes undetected for weeks and months, and that is what we see at our customers. Okay, what options do I have to see the dog and distinguish it from the carpet? Yeah, one thing is certain, I have to look very closely. So I need something or something that looks very closely so I can even see the dog here. Okay, another thing is also certain, I cannot apply some generic detection engine with static rules, thresholds, and logic here. Yeah, it will never detect a dog here. That is very important to understand. But unfortunately, we see this approach far too often today. The common approach is trying to detect such attacks using static correlation rules or other rule-based systems. And I would like to illustrate why this is problematic and why it's not scaled anymore with a very, very simple example. So we have our SIEM, right? So all logs go into the SIEM, all the security alerts, and we have rules like this. A classic example that I see almost every customer. Trigger if a user log in to more than 10 different systems within one day. Yeah. This is, let's say, a later movement example, right? So maybe we have an HR employee was phished via email, and now attacker took over the account and of this HR person and performs later movement, trying to log in to other more interesting systems to find the path to critical files or systems, for example. Yeah? And the approach of using rules to detect this here is completely understandable. But what are the consequences here? If you're relying on let's say, static thresholds, on filters, on this kind of correlation rules. For an HR person, it works maybe fine. Why should an HR person ever log into more than 10 different systems in a day? Okay, that's fine. But what about all the other accounts I have? What about admins or service accounts like backup or software distribution? Yeah, the rule will for sure trigger and generate some false positive. Yeah, and then you need to whitelist these accounts and so on and tune it, right? So, and if an HR account logs in maybe to 8 systems or to 12 systems in 36 hours, who defines these static values? Which value is accurate? Yeah, and this is really, really problematic. But in reality, what do you really want to detect here? In reality, you want to detect if a user or account log into an unusual or abnormal high amount of systems compared to themselves, or maybe to the department or the peers. This is what you are looking for. And for that, you need ULBA. Yeah, you see the challenges here. Correlation rules are great if you want to detect very specific, defined pattern. But if you want to go beyond that, then the results is often another rule for a very specific case and another one for a new attack pattern. And then you quickly have hundreds, thousands rules. And the challenge is that comes with them. It's like tuning, whitelisting, and in the end, still a lot of false positive. And if you have bad luck, you still miss the dog on the carpet, right? This is the reality what I see in all the SIEM projects, hundreds, thousands of correlation rules. Okay, here the summary of the challenges with like rule-based detection engines like correlation rules. Yeah, it can only detect known pattern. Yeah, you need exactly define if, then, trigger something, create an alert. It's very time intensive. Yeah, as you have seen in the slide, to maintain, to whitelist, to create, expand. Yeah, and also to fine tune. And then you have tons of false positives because the thresholds are very generic. They apply for all the users, for all the accounts. Yeah. And then if you have a new attack pattern, means often a new additional isolated rule. How often we hear from other vendors, oh, here is a new ransomware attack, whatever, please download this rule and enable this rule, and every time the same. Yeah, this is not sustainable. Yeah. And then the critical activities are not detected due to the static rule concept, static threshold, and the missing context. Yeah. Okay, I think I talked enough about challenges, what is not working and why it's bad and so on, but I'm here also today, of course, to present a solution for these challenges. And for that, I would like to go one step back to the basics. Yeah, so the basic is the log that we receive. Yeah, what we send to every SIEM, yeah, are the relevant raw logs and also some security logs, yeah, from my relevant systems in my organization, right? So I have a very simple example here that is coming into the SIEM. I hope you can read it on the stage there, but it's, yeah, fields are already nicely parsed. It's like you see at the beginning of the time, we have the host 1, yeah. We have then some IP addresses. I think it's a source, destination IP. We have a file, we have a message, yeah, large outbound traffic volume. We have a user and we have a process. But still I need to ask some important questions now. Yeah, and I need some answers that I can properly understand the context here of this log. Like, what host is it? Is it a server? Is it a workstation? Is it a domain controller? What is it for user? Is it an admin, service account, HR, employee, whatever? Is the user usually working with the host? What does file means? What large means? Large outbound traffic. What does it mean, large? Yeah, I don't know. I need to ask questions. I need to find out. And these questions, yeah, and the number of questions that arise from such a simple log can be enormous, as you can see here. Yeah, but you need the most of them to understand the context correctly and classify the case. It can be the range from, this is a normal user, yeah, using WinSCP, transferring some pictures from their last location to a file share. Nothing critical, but it also can be Barbara B. Salazar is a privileged user accessing host 1, which is the most critical system in my organization, and exfiltrating the most critical files like patents or your customer data. And this is a big difference. And you need to find out what a system needs to detect or distinguish between these two options or all the options in between. Yeah, and what does large mean? Is it 10 megabyte or is it 10 terabyte of outbound traffic? I don't know, based on these logs, right? Who defines what is large and what not? Yeah, and you may ask today, no problem. These days I have ChatGPT, I have my Copilot in my environment. Yeah, I can ask and so on. But still, you need to know which questions to ask the generative AI. Yeah, and the context around it. And now Exabeam can help here. Yeah, and let me show you how we address these challenges. It will be a little bit technical, but not that much technical yet. Okay, so what we are doing is, we ask all the questions for every log that is coming in automatically for you and provide the answers and context around that by using our risk detection engine. It's not that complicated as it looks like. I will walk you through it. So first of all, this is my mouse. Okay, we have features. Features, you can think about the questions. You have seen the slide before. Yeah, here are all the questions we ask. Next, we have the feature value. Yeah, these are basically the answers or result of the questions. And each event is evaluated against a family or group of these features, depending on the log type. Because I need to ask other questions if I have a process log, or if I have maybe VPN log or a file log. And the results creates a feature vector, which will provide a risk score based on the models, the context and rarity of such a feature vector. Yeah, this is very, very important. We will run through this in an example later on. Important to understand is that we have different type of features and questions. One of them are profile features, where our UVA and the models come into the game. So for every log, we are not only parsing all the fields, as you have seen the slide before, we also extract all the relevant information and creating different models with this data for every user and asset. And the result or big advantage is that the system automatically creates the individual thresholds for each user and each asset in your organization through the models across all the log sources. Think about the example with the login to more than 10 systems within 24 hours. You don't need this rule anymore, because for each user, we now define this threshold. What is normal and what is abnormal? What is the normal amount of access to systems in which time period? This is automatically what we do based on the logs we receive based on the models. And then for an HR person, it's a small number maybe. It's completely different number, threshold, than for an admin user or for a service account or for a backup account. Yeah? And by using more than 600 different type of models, yeah, which unique with its unique content for every user and asset, we create like a fingerprint for each entity, and this allows to detect this compromised credentials and credential-based attack. Because once the attacker is using my account, the fingerprint, the behavior of the attacker will not match my models. It will never match my behavior, and then the risk engine, by asking all these questions and finding out immediately that this is not Sergej anymore. This is something, a different person. Okay, let's jump a slide back, and I would like to go through this example here. So here we have, for example, questions like, let's say we have a Windows login log is coming in. Okay, then we're asking, the first question is the IP addresses, let's say the source IP or the destination IP in the log, is it on a blacklist? Yeah, we have a threat intel, whatever, and then we can ask, is it on a blacklist? This is an easy question. Yeah, nothing to learn. It's just a fact-based question, yes or no. Yeah, let's say no. Then the second one is trickier, unusual user to asset access. Is the user that logs in now to the server, is it unusual for the user using this asset? The only way to answer this question is, I need to know which systems the user accessed in the past, which system the user is usually touching. If I know that, I can say if this system is unusual or not. Yeah, here we need a model. Next one, is the user an executive? Because it's a different, if a service account or an executive account or an admin account is accessing maybe a domain controller. Depending on the answers, on the context, the risk score will go higher here on the right or will go lower. The next one, unusual Kerberos ticket option for the user. And this is exactly Kerberos ticket I need to access systems. How much Kerberos ticket I use within 24 hours. Gives me the answer how much systems I usually touch. And there we can easily, we have the model for each user. For this one, it's maybe 5 to 7. For the other, it's 20 to 30. And also unusual number of bytes in 24 hours. This questions makes not the sense maybe for asking when you log into the system. But if you have a proxy log is coming in, then we're asking, for example, we have a question like, is the data that the byte sending out to the web, is it usual or unusual for the user? Yeah. Then we are not asking this question, the last one, we're asking a different one. Yeah, based on the log type. For email, it's maybe like, is it unusual attachments or unusual email counts that he's sending every day? Yeah, based on the log type, we adjust automatically the questions that we need to ask. Yeah, the features, and then based on the rarity on the answers, we create a risk score. Yeah, this is the secret behind it. Okay, and all the advantages that coming by that. Yeah, by profiling, yeah, let's say we learn the behavior of all the users and assets. Yeah, it's way more accurate detection given every asset, every entity has its own baseline, and we don't need to create this in 24 hours, 10 times greater, whatever. This is not needed anymore. Therefore, less false positives. Fine-tunes automatically, it learns automatically. If a user behavior changes, the models adapts and so on. And the detection engine automatically asks the right questions and provide the relevant answers and the context. You just need to send us the logs. You don't need to create rules, nothing, just send the logs, and after a few weeks, you will get very good results. And very important, what correlation rules cannot do, we can detect unknown attacks never seen before, where we have no pattern, nothing. And this works by profiling all my assets and users in the organization, what we do. Everything what is new then or never seen before will be seen as abnormal. Example, you have a ransomware. This ransomware uses port 555 for its attack. No problem. You do not need to create a rule like, if I see port 555, then trigger, blah, blah, and so on. We will detect it automatically, because we baselined all your assets, all the ports for all users and all the assets in your organization. And we will trigger detection like first time port 555 used on this machine. Never seen before. First time port 555 used in this department, network zone, never seen before. First time user is accessing a service on 555. We don't need to write the rules. Yeah, but still the system will detect it because it's something completely new, completely never seen before. And we do it for all activities like logins. This was a network example, ports, DNS, proxy, email, database, file, and so on and so forth. Okay, this is how our detection engine works. Yeah, but now you have a great detection engine, yeah, and you have a cool detection, a really nice detection. Usually the hard work starts now for you, yeah, if you're a SOC analyst, yeah. You need to investigate further. You need to understand the scope, who's involved, and so on. And now speed and accuracy is also very important. Yeah, so you need to have all the relevant information ready to you on the desk with the context that you can quickly understand what is going on. And for that, we have our threat center with our smart timelines that provide all the relevant information and context and explain you, like you can see here, the full story of the attack. You don't need to go to the raw logs and query and whatever. You will get the full information, full information of this attack on your desk. I have a few screenshots here that are very static. because I don't want to jump to the demo now. But here you have our threat center, for example. Yeah, what you can see here, we have here somebody like your Brianna involved. Yeah, we grouped all the detections. We grouped it for the user Brianna. What we do under the hood, we can identify which accounts Brianna is using, which email addresses, which accounts, and we use it automatically because it's a challenge. If you have a user, they have maybe an Office account, they have a local account, they have a Salesforce account, they have whatever account. We have a patented technology where we able, based on the logs, combine all the accounts to an entity, and then all the logs are coming in. We can also then attach it to this account. You see here the risk scoring. You can click on how this risk was calculated, and it will show you the features and the answers and the questions. And here you see which rules are triggered. We have here something like abnormal amount sent outgoing for the as an email. Yeah, remember the question before. This is very similar. Then you see the users involved. Yeah, and you have here different options. You can ask our Exabeam Nova. I will talk about that a little bit later. Here you have a summary, what exactly happens, the next steps, recommendation, and so on. Yeah, but what you also can use is the thread timeline. Yeah, by clicking on the thread timeline, you will get all this nice information on the left side. All the activities belongs to this user. On the right side, you will get the context. Which rule triggered? You see the rarity here. You can see the model, you can see the features and all the stuff, and very quickly understand what is going on here. And also you see here, if you want to go deeper, yeah, if you like for forensic, we have also investigation timelines. So we have threat timelines, and the next level would be investigation timelines. And here we have really the raw events. Yeah, you see here, for example, we have here successful VPN login for this user, nothing wrong. Then we executed Mimikatz, and then we have here an analytics tool that triggered. And then you can see which models. You can have a look in the models. What is normal? What is abnormal? And here, this is an example. You see this 25 analytics rules. And this is exactly the features, the questions we have asked for this process. Nothing else. We have asked 25 questions, and the result is like this. Yeah, and then based on the results, we provide a risk score. Okay, Exabeam Nova, I touched a little bit a few slides before. What is it? What is Exabeam doing when it comes to AI? So we do AI and machine learning since 2012. Yeah, based with our UBA. We are really the most sophisticated, most installed UBA in the world. We have a very strong user behavior entity analytics, which is the foundation, the basis. Also for example, GenAI. Yeah, if I ask my Copilot and I don't have this context, or the Copilot has not this context, are not trained on the data, they cannot answer me the questions. Yeah, the foundation, still this kind of a models, normalization, extracting all the relevant data and providing the context is key that my GenAI can answer the questions that I ask. Now we are going further. We also have agentic AI, and we are using multi-agent AI. This is let's say a sub part of agentic AI with Exabeam Nova, and we use it in all different kind of our applications. This is a more proactive approach. Yeah, Gen AI, you have a bot that can do it like summaries, but you have to ask. Give me the content of this user. Give me the name of whatever. The multi-agent is more proactive. If you are investigating, they will proactively, it's like a SOC analyst sitting next to you and say, hey, look, please at this. Are you looking for this process? I have seen the same process with the other user. Should I show you the context, and so on and so forth? So this is the next evolution of this of AI, is agentic AI. And we use it in multiple applications already. We are applying it from Gemini. So this is the Vertex AI framework, and we're using Gemini there for multi-agent AI. For example, you can ask questions, but if you go to our outcomes navigator, it will give you some recommendations, which logs to bring in, and so on. You can also say, create me a dashboard, yeah? Or for example, if you log in every time and you perform every time the same search, then the agentic AI agent will recommend to you, hey, you're doing I have seen you doing all the time, every day, this search. Do you want that I create a nice dashboard for you? Yeah, this is like proactive supporting you, and we have it now in our product. Okay, my last slide, and I think I have 2 minutes left. Yeah, and I would like to conclude my presentation with this slide because it's important to know. If you already have a SIEM, that's great. Yeah, you can keep it. You don't need to replace it if you don't want. Yeah, 50% of our customers have a SIEM in place, but still, after spending a lot of money for the SIEM, still see the benefit and still want to use our detection engine and our investigation engine, yeah, on top of their SIEM. And we have a lot of customers also in Germany, and I think also in Italy. Yeah, so we are on one side a fully fledged SIEM with correlation rules, dashboarding, reports, and so on. But I have shown you today why customers primarily considering and buying our solution. It's because of the risk-based detection engine, which is in combination with UABA, which is the next evolution compared to the rule-based detection engine, and the timelines where we put all the detections, the context together, easy understandable for you to enable the analyst to investigate attacks very accurate and efficient. And all this is hosted in the cloud native, as a cloud native solution in Google. We are using all the Google tools like BigQuery, like Google Spanner and all the stuff. Okay, I hope this was interesting, and yeah, this was what I wanted to share with you. If you're interested, if you have questions, please reach out directly to Antonio, and yeah, thank you very much for your attention.
Thank you, Sergej. Thank you very much.
Thank you, Sergej. Grazie Antonio.